So here we have to understand about page tables. We have said that whenever we get a in the previous video we have said whenever we get a virtual page number, we will look the page table to find the PPN, that is physical page number, right? So the processor is using a page table to translate this virtual address to physical address. So page table contains an entry for each virtual page. So each virtual pages, their corresponding page, physical page number would be there. So for each virtual page, there would be an entry in the page table. So this entry contains what? This entry would contain a physical page number and a valid bit. What does page table's entry contain? So here, okay, I just set a timer by mistake. Okay, if you consider, 1 minute guys. Okay, if you consider, this is my page table looks. That means each of my virtual page number, there would be an entry in this page table, and this contains this virtual page numbers physical page number. This virtual page numbers in the physical memory, what is its page number, that would be there, and also a valid bit is there. Now we have to know why this valid bit is actually used. So if you see, there is a physical page number and valid bit. Now if valid bit is 1 means what? This virtual page maps to the physical page. That means there is, this virtual page has a physical page in the physical memory. If this virtual page is found in the hard drive, then that means valid bit is 1. That means the virtual page we will get the physical page, but that is present not in the physical memory, but it is there in the hard drive. And page table is very large, so I have already told you we will store it in our physical memory RAM itself. Okay, now page table's index is what? Page table's index is this virtual page number. Entry 5, that is if we have virtual page 5, let us say this virtual page 5, that would match us to physical. So first, if you wanted to find, we got virtual page number as 5, so page 5 we have to match, we have to find this physical page. So here we will check, okay, where is page 5? Here we will check its what is this physical page number. It is page 1, right? So page 1. So in our physical, and valid bit is 1 means what? It is present in our main memory itself. If entry 6 valid bit is 0, so this virtual page 6 is located on the hard drive. Here valid bit 1 means what? This page 1 is there in our main memory itself. But here if you see, this 6 valid bit is what? 0. Valid bit 0 means what? This is present in this is present in the hard disk. That is why the valid bit is that is why there is no page number given, because it is present in our hard drive. Understood? So then we have understood that the page table, where it is stored anywhere in this physical memory. Now the processor typically use a dedicated register which is called as page table register to store the base address of the page table in the physical memory. To perform a load or store, the processor must first translate this physical address, virtual address to physical address, and then access the data at that physical address. The process extracts this virtual page number from the virtual address and add it to the page table register to find the physical address of the page table entry. So how this page table is looking, how do we look this page table is that this we have understood that this page table is there in the physical memory, and there is a address typically for this page table which is known as page table address, page table register. There is a register which is there in the processor typically for where? For the page table. For what? For what this register is there? For our this is basically for what? This is basically for our page table. So for page table we have what? This processor, okay, this register, and this contains this page table register would store the base address of the page table. So first what happened is that first we will translate this virtual address to physical address to act, and then we access the data at that physical address. So the processor has to, from the virtual address, the processor has to extract this virtual page number from our virtual address, right? From our virtual address, what does the processor do? It will take this virtual page number and it will add it toward the page table register, which stores the base address. So from the base address, it will add this virtual page number that is extracted from the virtual address, and then we will find this physical address page table entry. So how you find is that this will help us to find the physical address page table entry. Physical address of the page table entry we will be able to find. So first what happened is that there is a register, page table register in the processor, which stores the base address of this page table. And whenever we need to translate this virtual address to physical address, this VPN has their corresponding PPN we have to find. So the virtual page number from the virtual address is extracted by the processor and it will add it to this page table register. So we will get the physical address of the page table entry. Okay, so now the processor reads this page table entry from the physical memory to obtain this physical page number. If the entry is valid, means it merges this physical page number with the page offset to create. Now if we have a valid bit, we get this physical page number. That we will merge it with what? We will add it with its offset. So we will get a physical address. This we already learned that how do we create a physical address with the physical page number plus the page offset. Now you have to understand, because the page table is stored in the physical memory, we have told already that we will be accessing the memory twice. First for what? For looking the page table, and the second for accessing the data. So 2 times we have to access the page table. So in order to prevent this, the solution for this problem, I told you translation look side buffer we will be creating, and that in detail of TLB we will learn in the next part. Okay, now using page table we have to perform this address translation here, 0x247C. So 0x247C, let's consider it is a 31-bit virtual address. So here first we will convert into 31-bit what? We will convert it into 31-bit binary form. From that, most significant 19 bits are my VPN and my later 12 bits are my offset. Let us say. Then the offset would be same for our PPN itself. Then we will check our virtual page table. So in the virtual page table we have got 2. Virtual page number 2, let us say. So we will check the virtual page number is 2. 19 bits 2. Offset is always same here. Now that virtual page 2 we will check in here, 0 and 2 here. Here is page number 2. Now page number 2's physical page number is what? 0x7ff. So here we will add in the physical address 0x7ff. Here you will see 0, 1, 2. So 2, it's a valid bit. Equal to 1 means it is present in our physical memory itself. So the page offset is same, which is 47C. Okay, I can detail do this address translation if you want. So here what happens is that you have 0x247. 31 bits virtual address means, let's consider the same. We are considering right now solving 31 bit virtual address. Out of that, 19 bits are what? Our PPN, and 12 bits are offset. And 27 bits would be our PPN, sorry, 27 bits are our physical address, out of which the 15 bits are my PPN and 12 bits are offset. This is the pattern I am going to do this question. So 7, C is what we know, 0, 0, 1, 1. 7 is what? 1, 0, 1, 1, 1 is my 7. No, it's not 7, sorry. 1, 1, 0 is 7. 4 plus 2. This is my 12. 1, 1, 1, 0 is 7. 4 is 0, 0, 1, 0 is 4. 2 you get it as 0, 1, 0, 0. Fine. Rest, for filling 31 bits, we will put what? Rest all 0, 0. This would help us to fill our 31 bits. Fine. Now, it said that the first 19 bits, that is this. Okay. the first 19 bits are my what? First 19 bits are my VPN. So that means 0, 1, 0, 0 to this. Okay, this 12 bit, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This 12 bits are my offset. So the rest of them are what? Rest of them are my VPN. So this is 2, page 2, right? 0, 1, 0, 0, 0 means what? Page 2 itself. 0, 1, 0, 0, 0, 0 is 2. So VPN I get it as 2. Fine. Now this is offset. That is, this is C, this is 7, this is 4. So 0x47C is what? My page offset. Now in the page table I will check page 2, 0S7FF is my physical page number. So 0x7FF plus offset I got it as 0x47C. That if you add, my final physical address is what? 7FF47C. This is my final physical address. This is how you are going to do address translation. I told you there will be 2 physical memory access. To solve this problem, we will be using translation look-aside buffer. So in the next video, we will be discussing TLB in detail. Thank you.